Hi everyone. In today's class, we'll see the concept of JK flip-flop. Guys, earlier we have seen one kind of latch, or I can call it as flip-flop, that is SR flip-flop or SR latch. So in SR latch, if you are going to have the inputs for SR00, you are going to get the state as latch state. Whereas if you are going to have 01, you are going to get the reset state. If you are going to have 10 as input, you are going to have set state. Means if s value is 0, you will get the reset state. If s value is 1, you will get the set state. This is where you can able to understand how the SR flip-flop is working. And one more kind of input possible, that is 1 1. When you are going to give the input 1 1, it is going to get as undefined or forbidden state, meaning that we cannot able to get the expected outputs as per, right? Meaning that basically if you are going to have Q1 is 0, Q1 bar should be 1. But for the case of input input 1 1, it is not happening. So that's the reason we mention it as undefined state or forbidden state. Okay, so the reason why we come across the JK flip-flop is, in JK flip-flop we are going to define the various states for 0 0, 0 1, 1 0 as like as SR flip-flop, and in SR flip-flop one state is 1 1, right? That input 1 1 is undefined, whereas coming to JK flip-flop, this state is also defined. That state is, I can call it as complement state. Complement state, right? So how you can get this complement state, all these things we'll see in further classes. Okay, so here basically what is happening now in JK flip-flop, if you are going to have S and R, the S value is be connected to J and R value will be connected to K. That's it. And all the remaining procedure is same as SR flip-flop only. Means basically guys, if you are able to observe how we are going to draw the SR flip-flop, right? So SR flip-flop we can draw it in two ways. One is through NOR gate, another one is through NAND gate, right? So now we will see those two structures. Basically when you are going to draw NOR gate, you are going to have two NOR gates, and this input will be coming from Qn bar, and this input is coming from Qn, and you know it is going to have one extra input line where this input line is coming from one AND gate. Guys, if you are going to draw this kind of structure, this is synchronous sequential circuits, right? Yes, we have seen the meaning of this also, right? As they are going to be under the single line control, meaning that at single point we can able to control the entire structure. So I can make it as here enable signal or level signal, or I can make it as edge trigger signal, right? Depending upon the type of signal what you are passing here, will be call it as a latch, will be call it as a flip-flop, right? Yes. If you are able to observe, so this is R and this is S. Okay guys, so this is what SR flip-flop using NOR gates. We can simply call it as asynchronous SR flip-flop. Okay, whereas coming to SR NAND gate, we are going to use 4 NAND gates. This is Qn. This input is coming from the another location, that is output of the second NAND gate, right? So for this, input is coming from output of first NAND gate, and you know this input is going to coming from once again from the NAND gate, and here also there is one more NAND gate is there. It will be connected like this, and here this will be S and this will be R, and these two are the clocks connected, right? So based on the enable or I can say that edge triggered, or I can say that it is level triggered. Depending upon the type of thing, they will be calling as flip-flop or latch, right? So as it is given, and this will be given bar. Now this one also I can call it as asynchronous SR flip-flop using NAND gates, guys, right? So this is with respect to NOR gate, and this is with respect to NAND gate. And we come across another kind of sequence circuits. Those are synchronous sequence circuits that you remembered, right? So if you haven't gone through the earlier video, you can go through that so that you can get idea how synchronous SR flip-flop works, and using NAND as well as NOR gates, guys. Here this should be synchronous, guys. Why it is synchronous? They are under the control of single line. This is synchronous and this will be asynchronous. Asynchronous SR flip-flops we have drawn, right? Meaning that there is no control over asynchronous SR flip-flops, whereas coming to here, they are under the control. Okay, fine. Now coming to JK flip-flop, basically how can we draw the JK flip-flop means? So here JK means like not J Krishna. It's a kind of an author who has done this. So his name is Jack Kilby. Jack Kilby is the researcher. He has done this. He has implemented this JK flip-flop. Okay, fine. So how he done? So he tried to construct in a different manner so that where we can able to use the 1-1 input also in different manner. So for that he did different modifications. So I am going to use black color here, so to make it clear. So here the QN bar should be always connected at the S side. Always should be connected at the S side. Meaning that whatever the output that I am going to get at the QN bar, that will be acted as input at the S side. Okay. Similarly, whatever the output that you are going to get at the Q1 side, that same output is going to be given as one more input at the R input side. So now, if you are able to observe, for time being, I am giving just the giving names as this as A and this as B, C and D. Guys, so if you are able to observe, so how we are going to implement JK flip-flop? We can implement JK flip-flop by simply taking SR flip-flop, where two AND gates are going to replaced with the 3 input 2 AND gates. Replace with 3 input AND gates, and QN output will be connected to R input side and QN bar will be connected to S input side. So this circuit we can call it as synchronous. This circuit will be called it as synchronous JK flip-flop, right? So what are J and K, right? So here J and K is, I said, like J should be connected to S, meaning that always S value will be connected to J and R value will be connected to K. That's it. So this is what synchronous JK flip-flop. Coming to synchronous JK flip-flop using NAND gates. You can simply do the same process only. But the thing is, like I said, like QN bar should be connected to S, right? So if I say that this is my input required, so here the input should be connected from which location? QN bar. This is important, right? So I said already, right? So QN bar should be connected to S side, and R input side input should be connected from QN, right? Yes. So this is what the circuit we can call it as JK flip-flop, right? But the thing is, here S should be connected to J, K should be connected to R, right? Now I can call the restructured thing as synchronous JK flip-flop, right? Yes. So similarly, we can go with asynchronous JK flip-flop as well as asynchronous JK flip-flop using NAND gate also, right? So we'll try to draw. So asynchronous JK flip-flop using NOR gates. Similarly, we can draw one more thing, asynchronous JK flip-flop using NAND gates, guys. So the hard and fast rule is you have to simply take the SR flip-flop. So you can take the asynchronous SR flip-flop, right? So how you are going to take the asynchronous SR flip-flop? You are going to take basically NOR gates. NOR gates. Here this input is connected from the other side, where that is Qn bar as output, that will be connected, and here this input will be connected from the output of Qn. This is basically a kind of a common thing where it is a memory element, right? And you are going to be connected one line, and this will be connected by one line, right? This is what R and S we can call basically as asynchronous SR flip-flop. Asynchronous SR flip, right? Meaning is, as there is no control line here, meaning that we cannot able to control, right? S can be any value, R can be any value. So this is what I can call it as SR flip-flop. Similarly, asynchronous SR flip-flop using NAND gates means, so as like the same thing only, NAND gates, one input will be yes, the other input will be Q bar. So I can call it as Qn bar. One input will be R. This input you are going to get it from Qn, right? So this is what we can call it as asynchronous SR flip-flop using NAND gates. Here this should be using NOR gates. Okay. Now our aim is to construct asynchronous JK flip-flop, right? So if you'd like to construct asynchronous JK flip-flop, the simple thing is you can able to construct, right? So S should be connected to J, R should be connected to K, and S should be connected to always Qn bar. So you can make sure to connect like this, right? And here this input will be connected like this, and it will be getting this kind of thing. So this is what asynchronous JK flip-flop using NOR gate. Similarly, asynchronous JK flip-flop using NAND gate means what? So this should be connected to J, and it will be connected to K. And for S side, you have to connect over Qn bar like this, right? Similarly, the output of Qn side, you have to make sure to connect like this. This is what asynchronous SR flip-flop, right? So basically the working of asynchronous SR flip-flops or asynchronous JK flip-flops, that we will see in the further videos. Okay, so this is what all about the basic of JK flip-flop. In the next video, we'll try to show how we can derive the characteristic table for the JK flip-flop. Okay, I hope you understood clearly.